Okay, today I'm going to walk you through a tuning exercise on one of the models. So what I've used here for my data file is I've used the iris data set. So those of you that have been through the R class will recognize, or have used R before, will recognize the iris data set. It contains information about flowers. So there's 3 different species of flowers, and it contains the 4 variables sepal length, sepal width, petal length, and petal width. So first thing I'm going to do is some exploratory data analysis. And here I'm seeing we have a population of 50 of each of the types of flowers, roughly distributed between all 3. Running a scatter plot first, we can see that there's some tight groupings here, so there does appear visually to be a relationship here. Also looks like there's some kind of a linear relationship going on. But if you want to just talk about it from a predictor standpoint, you can see that the petal length, the petal width, these are all predictors that'll group them together. So in this case here, the setosa flower looks like it's going to be really accurate to be able to predict based off of petal width. But then as you go out here, you can see that the versicolor and virginica, there's some overlap. So in those cases there may be some error introduced if you're looking just at the petal width. So I'm going to go through the modeling process. I'm going to go ahead and set the ID to the record ID. That's just an ID that I've created on the record. I want to exclude that from any kind of analysis. The species is the target, so I'm trying to predict the species based off of these 4 predictors right here. Running it through a partition. Now I got my partition size set to the defaults of 50 and 50. Probably would want to adjust that, or maybe even include a validation partition. Maybe adding additional partitions may also be a good idea. But in this case, small data set, it's pretty known, and we can see visually, we can see that there's a relationship going on there. So I'm going to leave it just to the defaults here. And then I'm going to go ahead and run the model itself. Now the model, I'm going ahead and using the partition data, make sure that that's checked. I'm going to rank based off of the training partition. And then I'm also going to calculate predictor importance, and I'm going to calculate the lift for use in analysis. After building the model builds 3 individual models here, the highest of which is this logistic regression at a 97.5% accuracy. Now it's using all 4 predictors in order to come up with that number. This is also using an ensemble, so right now it's going to use all 3 models in order to predict. If I wanted to just check and just use just the logistic regression, I would do that by unchecking here and then clicking the deleted unused models. Now, going over here to the analysis, I want to go ahead and run this. It takes a minute. Kind of as expected, we see out of the training data set, 100% of it predicted correctly. Of the testing data set, 95% predicted correctly, with a 5% fallout. So again, this is a pretty high prediction rate. This is a pretty good model, tuned model. If we look at the matrix mapping the predicted species to the actual species, we can see that setosa predicted 100%. We can see virginica had 2 that were off, and versicolor had 2 that were off as well. And if we look at the lift curve comes out as expected to as well. So your model should look something like this, but it'll be different because you'll be using a different data set. Also, when it comes to the partition, you'll probably be breaking off the testing and the training partitions so that you can see individual branches. Now you can also take it the further step of, instead of using an ensemble model like this, to go ahead and build a logistic regression. If I do that, then the actual tuning on this becomes a lot more accurate. So although I'm at a pretty high rate now, I could even get a closer rate by breaking that off and doing some internal tuning on the individual model itself. So that's pretty much the exercise that you have to do. And then for next week, to the deployment stage, is you essentially take this table that you would create off of this model, and then you would use that to save out. So this would be the entire stream, building a model from the source file here all the way to the target file here.